morning, students. Last class we did the working of the quicksort, how the quicksort works. So what we have seen that it is the divide and conquer based approach where we are dividing the number of elements and then we are combining them and getting the sorted list of elements. So on the same approach we have another algorithm also that is based on the divide and conquer theory. So the second algorithm that is based on divide and conquer approach is merge sort. So what the merge sort will do, again it will take number of elements and it will keep on dividing the numbers, the elements, or you can say we have a list of elements, we say we have the array of elements. So the array of elements basically we will keep on dividing the array till we get the one element only. So we will be having the number of elements in different arrays. So we will have one array with one element like that. And after getting those one element, we are going to merge them. As such, we are getting the sorted list. So how the merge sort works basically, we will see with the example. Suppose we have the list of array 6, 4, 2, 1, 9, 8, 3, 5. So suppose this is the array of elements we have. And we have to apply the merge sort to get the sorted array. So what we will do, as divide and conquer approach, first we have to divide. So how the divide will work, we have to divide the array based on the number of elements. So how many elements are there, accordingly we will divide, and n by 2, if n is the input size or the input size of the array, then n by 2 we will take basically the floor value of n by 2 and we will divide the elements like that. So how many elements we have now in the array? 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 2 is 4. That means we are going to divide the elements of the array into two sub-arrays where each sub-array will contain 4 elements. So it will be divided into two. One sub-array will contain the first half, that is 6, 4, 2, 1, and the second sub-array will contain the rest 4 elements 9, 8, 3 and 5. Again, now we will divide these sub-arrays according to n by 2. So now the input size is 4. 4 by 2 is again 2. So that means this sub-array will be divided into two sub-arrays where each sub-array will contain 2 elements. So it will be like 6, 4, then 2, 1. Similarly, here 9, 8 and 3, 5. So we have these sub-arrays. Again we will divide this. Now we have the arrays of 2 size. So 2 by 1, that means 2 by 2 is equal to 1. That means each array will contain one element. So 6, 4, 2, 1, 9, 8, 3 and 5. So now you see we have the one element in the array separately. Earlier it was combined. Now we have separate elements, that you can say we have number of arrays in which we have the separate elements. This was the divide. In the divide and conquer approach, this is the divide thing. Divide portion you can say. This is the divide portion. After dividing, till we are reaching the one element, we will keep on dividing the array. After dividing, now the conquer part will start. So how the conquer part will work? So what we had 6, 4, 2, 1, 9, 8, 3, 5. This portion we have got from the divide approach. Now when we start the conquer portion or the conquer approach, then what we will do, we will keep merging the arrays. Now we have these elements separate. So we will keep merging the elements and we will keep them in the sorting order. So by two elements we will take and we will combine or we will merge. So while combining, we have to see, we have to check, or we have to swap, or we have to interchange accordingly. We have to check which number is greater and which number is less. Accordingly we will sort. So if we are going for the ascending order, so we will swap if the number is greater. So now we will merge it. So two elements we will pick. So now when we are going to merge this 6 and 4, so 6 is greater than 4, that means 4 is going to take place of the 6. So how it will be merged? It will be merged like this, 4, 6. Similarly, now you will merge this 2 and 1. So 1 is less than 2, so it will come on the first place, 1, 2. Similarly, 9 and 8, 8 is less than 9, so it will come at the first place. 3 and 5, 3 is smaller than, so it will be on the first place. So like that. Again, we will, now we have 1, 2, 3, 4 sub-arrays. Now we will again combine them, or we will merge two arrays, two sub-arrays again, and again we will keep on this thing that you have to merge the arrays according to the sorting order. So when we will merge these two, so we will combine again and we will check. So first element of the first array will be compared with the first element of the second array. So when we will compare this 4 and 1, so 1 is greater than, 1 is less than 4. So that means 1 is going to be at the first place. Now this 4 will be compared with the 2. Again 2 is less than 4. So next element that will be merged will be 2. Then this array has finished and we can put the elements of this sub-array. Now no need of comparing because this sub-array already has the elements. Those are already sorted. So we will put all the rest of the element here in the merged array. Same procedure we will apply here and we will merge it. 8 will be compared with 3. 3 is less than 8, so it will come first in the resultant sub-array. Similarly, now 8 will be compared with 5. 5 is less than 8, that means 5 is going to take place in the merged array first, and then rest of the element of the left array will be put in the resultant array. So now we have two sub-arrays, and remember these sub-arrays are already sorted. Inside it, these are sorted. Now we are going to merge these two. The same process we will apply. The first element will be compared with the first element of the second sub-array. 1 is less than 3. That means in the resultant array, 1 will come at the first position. Then 2 will be compared with 3. 2 is less than 3. That means 2 is going to take place the next position. Then 4 will be compared with 3. Now 3 is less than 4, so 3 is going to come in the resultant array first. Then 4 will be compared with 5, that means 4 is less, 4 will take the position. Next position will be taken by 4. Now 4 has come from here. Now the 6 will be compared with 5. So 5 is less, so 5 will take the position. Now 6 compared with 8. 6 is less, so 6 will take the position. Now this sub-array elements are exhausted, list is empty. That means we can take rest of the elements from sub-array as it is. No need of comparing because these are already in the sorted order. So you can see we had the elements 6, 4, 2, 1, 9, 8, 3, 5. Now we have in the ascending order 1, 2, 3, 4, 5, 6, 8, 9. So like this merge sort will work. So this was the conquer portion basically that we will say. This is the conquer portion because it is we are conquering the sorting, or we are merging the basically elements to get the final output of the sorted list of elements. So this is the merge sort, this is the working of the merge sort. Next working we are going to discuss is the heap sort. How the heap sort works? As the name suggest it is going to sort the elements or sort the array with the help of heap. Now what is a heap? Heap is nothing but it's a tree basically. Okay, so how the heap sort work basically? The first step is basically we have to create heap. When we are creating the heap, remember, either we are going to create min or max. Anyone can be chosen. Min heap and max or max heap. Min heap means every node is less than its descendant node. This is the condition for creating the min heap. Max heap is the reverse. Every node is greater than its descendant nodes. And we can put greater than or equal to here, because if number of the elements are same, then equal to we have to say, so less than or equal to. So less than or equal to or greater than or equal to. For example, suppose this is a tree. 4, 2, 3, 1, like this. So if you see here, every node, now if you see the root node is maximum element in entire heap elements. So 4 is the maximum, 4 is at the root. This is a, similarly if you see this node, intermediate node 2 is greater than its descendant. Descendant is 1, 2 is sitting at the parent node basically. Similarly 3 doesn't have any leaf, you can say the node, but it has the external node, so it will be null node. So basically it is also greater than its children. So this is an example of max heap, where each node is greater than or equal to its descendant nodes. Similarly, if I reverse this, for example, 1, this is 2, this is 3, this is 4. So if you see here, this is the case of min heap, where if you see 2 is greater than its children, less than its children. Similarly 3 will be less than its children only because it doesn't have any children. 1 is less than its children, children are 2 and 3, 1 is less than its children. So this is a min heap basically. So while creating the heap, we have to check always, we have to create either max heap and min heap. So why we are creating max heap and min heap? There is a point, because when we are creating the max heap, the maximum element out of all the elements will be sitting at the root. Similarly, if we are going with the min heap, that means the smallest element is going to be sit at the root. So that means we can pick, every time we can pick the smallest or the biggest element. And if we keep on adding them into some separate array, we are going to get the sorted list. So this is what we are going to do. First step was the create heap, either max or min heap. After that, we will, you can say, make the heap again basically. Okay, we will delete the element first, delete element, or you can say delete root element, and after deleting the root element, make heap again. With the same procedure, we are going to make heap. So we will keep on repeating this step. We will create the heap, we will delete the root element, then we will rebuild the heap again. So this rebuilding will till we are getting only one node in the tree, it will repeat it. The step will be repeated, and in the last we are going to get the sorted list. So we will take one example and see how it works basically. So suppose we have the elements. We will take one small example. Suppose we have 4, 6, 10, 9, 2. These are the elements that we have in the array, and now you have to sort these using heap sort. So the first step in heap sort is basically you have to make the heap. Max heap or min heap, we are taking the case of min heap. The simple way of making the heap is just take the elements put, because this is a binary, okay, heap is a basically binary tree, so the one node will be having only 2 children. So just you take the nodes, keep the node and make its children. No need of, in the first step you need not to see whether it is going to be less than or greater than, because these are not the binary search tree where you have to see whether the node is greater than or the less than is children and all that. So first node is 4, keep it at the root, next is 6, keep it to the left, then 10, okay, 2 finish. Now next is coming 9, 9 will go to the left of 9 and 2 will go to the, left of right of 6. So like that we will make. This is the simple, you can say the binary tree, simple heap. Now when we are going to create the min heap, then we have to do the comparisons and all that. So for making it to min happen, so now let's make it min heap. So for making it min heap, there's a simple formula, heapify method we are going to use. We are not going to touch the leaves node. We will not touch the leaf node, upper one level we will check. Okay, so this is the leaf node level, this is the another level. So we will check here, this is the 6, okay, 6, we have to check whether it is less than, because we are going to make min heap, so we have to check whether it is less than its children. No, it is, yes, one child is greater, it is less, 6 is less than 9, but 6 is not less than 2, that means you have to interchange their position. Now the child will take the place of parent and parent will take the place of child. So what the result will be? It will be 2, 10, 9, 6. This level, okay. We are at this level. This is okay because it doesn't have any children. So we will move another level. We will check here. Now 4 is greater here than 2. So it will swap the position. 10 is greater, okay, but 2 is less than 4. That's why they will swap their place. So we will have the tree like this. So we have this tree now. This is, now we have finished all the levels. We have reached to the, we have started from the last level and we have reached to the first level. So that means the whatever the heap we were going to create, it is done. Now if you see here, the smallest element is sitting on the root. So that will always happen when we are going to create a min heap. Always the smallest element of all the nodes will be sitting at the root node only. So now what we will do, we will delete. The next step is delete the root element. So we will delete the root element and suppose we are keeping in this element. So the root element was 2, it is deleted. So now when the root is deleted, obviously you have to make the heap again. It is needed because now the tree doesn't have root. Root is a must node in the tree. So how we are going to reheapify or how we are going to make the heap again basically. Again you have to see that because we have chosen that we are going to make the min heap. So you have to make the min heap again only. Don't mix this key, okay, once we are making min heap and then we are making max heap. Either you have to choose max heap or you have to choose min heap. So because we have chosen in the first min, so we are going to again building the min heap only. So while rebuilding the heap again, min heap again, so root is deleted. So who is going to take place the root, position of root when root is deleted? So that according to binary tree, the leftmost child, okay, the leftmost child that is sitting there in the binary tree, it is going to take place of the root. So which one is the leftmost child in the, you can say in this tree? So if you see in the left subtree, we have 2 children, 9 and 6. So this, according to the complete binary tree, this 6 is going to take place the position of 2. So how the tree will look like now? 2 was deleted, 6 is going to take the position. Here it was 4, here it was 10 and here it was 9. So this was the, now this is the position of the nodes when the root is deleted, but it is not min heap. So you have to create it as the min heap, you have to build the min heap. So again we will see this, from this node we will check This node is smaller than its children, well and good. This node is smaller than it because it doesn't have children, this is also good. But here you check, this node is not smaller than its children, 4 is smaller. The child 4 is smaller than the parent. So you have to swap their position. So when we will rebuild it, so it will be like 4, 6 will go this side, 10 this side, and 9 this side. So now if you will see, we have reached to the root level. That means we have finished the rebuilding the min heap again. So again, if you will check, the 4 is the smallest element of all the nodes. It is sitting on the root. Repeat the process. Delete this element from the root. Put it in the array. So our array was here already having 2. We will add 4 here, and we will go to our heap again. 4 is deleted. Already deleted, so we are left with 6, 10 and 9. So which node is going to take place of the 4 or the root node? The leftmost is 9. So that means 9 is going to take place of the root, and now the tree is like this, heap is like this. We have to check whether it is a min heap. No, it is not min heap because 9 is greater than 6. According to min heap, the parent node will be smaller than its descendant, but 9 is greater than 6. So basically 6 is going to replace 9. So 6 will sit at the top, 9 will here, and 10 will here. Now it is min heap. So we have got the min heap. Delete the root. That means delete 6 and put it in the array. So 6 we got here. From here it is deleted. So which one is going to be at root? Leftmost. That means 9, and 10 will be at the right side, or the right child of 9. So will we check now? Heap is there, whether it is min heap or no? Yes, it is min heap because parent node is less than its children, only child. Okay, so this is min heap. So what we will do here? We will delete 9 or remove the 9. We'll keep it in our array 9. And we will go to our heap again to rebuild it. So the only element now left is in the heap is 10. So 10 will be deleted again and will be kept in the array. So here we will keep the 10. Now the tree is empty. So we have to repeat the process till the tree is empty. Now tree is empty, and what we have got here? 2, 4, 6, 9, 10. The sorted list of elements. From where we have started? We have started from 4, 6, 10, 9, 2, and what we got the resultant array 2, 4, 6, 9, 10. So that means array is sorted. So this is how heap sort works. The one thing that you have to remember in the heap sort is that we have to go either max heap or min heap. Any type of heap we can go, but we have to decide in the beginning, and whatever we have decided, it will be applicable to the through of the problem. This is one thing that should be taken care of. Otherwise the process is same. Create the heap, min heap or max